All right, so one of our first rules that we can throw into the mix is the product rule for exponents. This really helps us when we have two things and both of them are raised to, say, an exponent. And it's a great way to actually put them together so they only have one thing raised to an exponent. Now the way this rule works is we want to make sure that both the bases are exactly the same. So I have a and a as my base. If they are the same, then it says we simply need to take each of their exponents and add them together. Now it seems like a little bit of an odd rule how you can all of a sudden start with multiplication and end up with addition, but let me show you an example of why this works. And I'm going to base it off of just what you know about exponents, that it's repeated multiplication. So here I have 2 to the 4th power being multiplied by 2 to the 3rd power. And let's pretend I knew nothing about the product rule. Well, I could start interpreting this by using repeated multiplication. So 2 to the 4th power would be 2 times 2 times 2 times 2 until I had done that 4 times in a row. Then I could do the same for 2 to the 3rd power. So that would be 2 times 2 times 2. And you can see what we have here is a whole bunch of 2's. They're all being multiplied together. So there's even no real need to put on those parentheses. So I'll just write 2 times 2 times 2 until I got all of them written down. Now, as long as I have all of these 2's written out, we said earlier that exponents are just repeated multiplication, so I can actually package these all back up. And if you count how many are here, it looks like we have 7 total. So I can say that this is 2 to the power of 7. Okay, so now comes the really important part. If you look at our original exponents that we used, the 4 and the 3, and you add them together, you can see that sure enough it does add to the 7. And the reason why this is happening is because you're simply throwing in a few more numbers to multiply by and incrementing up that exponent. So that's why the product rule works. Let's go ahead and practice with it now. In our first one, I have negative 7 to the 5th power multiplied by negative 7 to the 3rd power. So the first thing you want to recognize is both those bases are the same. So we'll just really focus on their exponents, the 5 and the 3. I'll write this one as negative 7 to the power of 5 plus 3. And then I could go through and actually, add those two things together. So negative 7 to the 8th power. And you could simplify it further from there if you wanted to, but I'm just going to leave it like that so you can see the product rule in action. All right. Now the next one will involve a little bit more work, and that's why I put in the negative 4 and the 3. Before I can get too far, I'm going to start rearranging the location of the 4 and the p's raised to the exponents. What really allows me to do this is the commutative property for multiplication, that the order of multiplication does not matter. And this is just helping me organize things a little bit better so that I have my numbers all in one spot and my exponents all in one spot as well. Okay, so that looks good. With the negative 4 and the 3, I'll just straight multiply those two together and get a negative 12. And with the other two, I can see that they're both the same base of p, so I'll look at adding their exponents together. So p to the 5 plus 8. This will give us a negative 12, p to the 13th power. Not bad. All right, one last one. Let's see if we can use the product rule on that one. Looking at this one, you'll notice that they both have a base of 6. One is raised to the 4th power, one is raised to the power of 2. But there is a slight problem with this one. This one is dealing with addition. And the product rule, the one that we're really interested in, this is for multiplication. Well, since the product rule only applies to multiplication, it means we can't use the product rule here. Even though that my bases are the same, it's simply not going to work here. If I did want to continue this one out, I wouldn't use the product rule. I'd simply take 6 to the 4th power, maybe see what value that is. So I get 1296. Then I'd take 6 squared, 36, and I would add the two together, so 1332. But again, notice how we do not use the product rule since it has addition there on the bottom. Let's try a few more examples and see if we can really recognize the product rule in action. So I've thrown in a few more variables this time. The first one is m times m to the 4th. It's really tempting to say, hey, maybe this one is just m to the 4th. But if you see missing powers, like on that first one, assume that they are 1. That way you actually have something to add. So this would be m, 1 plus 4. Now that you actually have your exponents added together, we get simply m to the 5th power. Not bad. Now, even though if you strictly look at the product rule, it only talks about putting two things together, you can even apply it for more than two things. In this one, I have z squared times z to the 5th times z to the 6th. And we can really apply the product rule as long as we do it two at a time. So let's just take the first two z's here. This would be z to the 2 plus 5. And we'll get to that other z in a bit. So now I can see that I have a single z to the 2 plus 5 and z to the 6th. That simplifies into z to the 7th. And now I can put these two together. Z to the 7 plus 6. And that would be z to the 13. And we could have even taken a much bigger shortcut if we simply just added all three of them together. And don't worry, you can definitely do this as long as all of their bases are the same and you are dealing with multiplication. All right, one more. This one is 4 squared multiplied by 3 to the 5th. Well, we're definitely dealing with multiplication here, but again, this one has a little bit of a problem. Notice how this one, the bases are not the same. Well, the condition for using that product rule is that we need the bases the same and we need multiplication, and so we simply can't use the product rule here. If we're going to go any farther with this one, we're simply just going to have to evaluate these exponents. So 4 squared would be 16. And then I'd go ahead and multiply that by 3 to the 5th power. $243. And then multiply the two together, so 3,888. So again, be very careful that the conditions of the product rule are met before you try and use it.